Alright, so let's go over the describing waves page. This is it actually looks really complicated, but it's not very hard at all. Disregard these links. They're probably dead links. We haven't used them in quite a while. They might work, but don't worry about those. Alright, so number one, we are essentially just doing what we did a few pages ago where we're like labeling the waves. So all we're going to do is label. They just want us to count how many in each and then label the letters, right? So crest, remember, crest is the peak, the very, very top, right? So right off the bat, hopefully you see 2. I see 1, that's the very peak. 2, that's the very peak, so B and E. Notice that I, it's not the peak, so that's not the crest, right? So I'm going to put B and E. That's my peaks. Trough is the lowest point. This is, pretty standard, pretty straightforward. D and G, right? Pretty easy. Everything else goes here. So just start putting in everything else, right? Everything else goes there. Okay, so the wavelength of the wave in the diagram below is given by a letter blank. And the amplitude of the diagram below is given by the letter blank. So remember that the wavelength in a diagram is one part of the wave to the exact same part on the other side. Doesn't always have to start at the same position, but one part to the exact same part. So for example, if we look at C here, notice that this part, the beginning of C is where it's going up, right? So if we're doing this, it's going up here. So this part over here, it's going down. So that's not the same part. So it's easy to get confused and look at C and be like, that's wavelength, but it's not, right? Same exact part. So if we were doing wavelength with C, it would be here to here, because this is going up, right? So it's not C. I just want to be clear. It's a pretty easy one, but some people get a little confused. So that's going to be A. That's our complete wavelength. So peak, peak, right? Now, amplitude. I think amplitude is that. Yeah, amplitude. So remember, that is the baseline to the outside. So in other words, it's the middle to either the top or the middle to either the bottom. Not both, right? So B is not the amplitude, because B is both, the very top to the very bottom. So we don't want to use B, right? We want to use the middle to the top or the middle to the bottom. In this case, they give us the middle to the bottom, right? So that's D. Easy. All right, let's look at number 3. Blah, 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 blah. Let's look at the questions. They want the wavelength. They want the amplitude. Pretty straightforward. It looks like it's measured in centimeters. So you can get a ruler if you want. Unfortunately, I only have like 3 feet meter sticks, but it's okay. So wavelength, remember, wavelength is from same point to same point. So I'm just going to sort of freehand this. I hope you pause and do it more accurately, but whatever. So let's see. I'm going to start here. So right here at the very bottom is about, so this is 10, right? This is centimeters. 2.5, 0.6, 0.7, 0.8. We'll say 2.9. So we're starting at 2.9, and we got to go to the exact same spot, which is going to be about 6.6. So remember, it's the difference between these two. So 2.9, 3.9, 4.9, 5.9 to 6 is about what? I'm going to calculate it. 6.6 minus 2.9 is 3.7. So we did that freehand. Remember, we did very bottom to very bottom, right? We could have just as easily done what very top to very top, but then we'd have to do like 1 to 5 or something like that, a little less than 5. So I got about 3.7. I can tell you that the key says 3.8. So we did, I'd say, a pretty solid job. I'm going to go ahead and put 3.8 because that's what we're rolling with the key, but nevertheless, we free-handed it, and that's good. All right, amplitude. Remember, it's from the middle to the top or middle to the bottom, right? Not both. So with that being said, I'm just going to do right here because it's closer to my little measuring thing, right? So it looks like it starts at about 0.9, 0.8, and it goes to about, what is this? 1.5, 6, 7. I'd say like 1.8 maybe. So our amplitude, well, let's see, from here to here, it starts a little, about 1. They say about 0.8 centimeters, so I'm going to go with that. Oop, 0.8 centimeters. Okay, so just middle of the top, middle of the bottom. We don't have to be precise or accurate here, just, you know, as long as we know how to do it right. All right, let's keep rolling. Okay, the number of cycles of a periodic wave per unit of time is called the waves. So, a couple things to remember. We're dealing with period and frequency. So, frequency is F, period is uppercase T. Period is always in seconds. It's a length of time for one cycle. And frequency is in hertz. And that's the cycles per 1 second. It is confusing. Don't worry about it. Just go with it. Eventually you'll get it and it'll make sense. There's a formula to find them both if you have the other. So frequency is 1 over period. 1 divided by the period. Period is 1 over frequency. Pretty easy, pretty straightforward formulas. Okay, so the number of cycles, remember if we're dealing with cycles, that's hertz. Otherwise it would have said the seconds, right? So we already know this one per unit of time is called frequency. Right here if you don't know how to spell it. All right, any repeated or periodic motion can be described by a frequency. Okay, for instance, the frequency rotation of a second hand on a clock is, so remember it's 1 point, right? Tick, tick, tick. So the frequency is 1 over 60 hertz. Bam, so that's A. All right, a pendulum makes 40 vibrations in 20 seconds. Calculate its period. So we already talked about the formulas. We wrote them off to the side. Let's figure out, first we need to figure out how many vibrations it's making in 1 second. That's pretty much what we need to solve. So we know if it's making 40 vibrations in 20 seconds, we need to find out how many vibrations it's making in 1 second, right? So 40 in 20 seconds equals 2 vibrations a second. That's the frequency is 2. So frequency equals 2. This frequency is number of like complete cycles in 1 second. So it's making 2 a second, right? So in order to find the period, we just plug that into the formula. So period equals 1 over frequency. So period equals 1 over 2. And we're going to convert that to a number, regular number, not a fraction. So our period is 0.5. And because it's period, we know it's in seconds. So I'm just going to put seconds here. Cool. So 0.5 seconds, easy. That's done. So, okay, 8 minutes. I might go to the next page. All right, so these are a little fast, so I'm going to go ahead and do them. Let's refocus here. There we go. All right. Olive Udadi accompanies her father to the park for an afternoon of fun. While there, she hops on the swing and begins a motion characterized by complete back and forth. So think of a pendulum, back, forth, every 5 seconds. So 1 complete cycle every 5 seconds. Remember what I said. Period is in seconds. Frequency is in hertz. So they're just straight up telling you. Well, you know it's not the speed, because speed isn't in seconds. Period. That's the period, straight up, because it's in seconds, right? 1 cycle. It's how many seconds for 1 single cycle? They say 1 cycle, right? All right, number 8. The frequency of all of this periodic motion in 7 is, so now it's just saying, yo, find the frequency. Well, we found the period, which is 5. Frequency is 1 over period, which means 1 over 5 equals about 0.2. And it's hertz because it is frequency. Units are important. All right, a period of 5 seconds corresponds to a frequency of, well, that's kind of free, right? It's the same thing, 0.2. But they're hammering in the point. A period of 261 hertz sound wave is, so remember, you see hertz, you automatically go frequency, right? So we need to do 1 over 261, and that should give us the period. So I've got the key, but I'm going to do it in the calculator anyways. 1 divided by 261, Control Enter, 0.003831. Yep. So 0.00383. That's fine. I'm going to take care of the 1. And we know because we're talking about period, it's going to be seconds. I'm going to write SEC so it doesn't look like a number. All right. Yeah, we got room. The frequency of wave increases as the period of the wave decreases, right? So just think about it. Periods in seconds. So if the time for one cycle goes down, less time for it to go down, that means it's probably more frequent, right? Just thinking like if you're swinging on a swing and it takes you 10 seconds to go forward, backward, forward. Well, all of a sudden if it takes you 5, the frequency is probably going to increase, right? Because you're doing it in a faster speed. So number 11, A. All right, number 12. Speed of wave refers to its what? How far at a given point travels per unit of time. This one. So we're just talking about general waves. I know that it's very tricky because it's like sound versus light, but how far a given point on the wave travels per unit of time. So how far the crest travels. All right, write the 2 equations that can be done to determine the speed of a wave. Awesome, already done. Very important. I believe the next page, probably in a couple pages, definitely the next page, but in a couple pages you'll need all these. These are just 2 formulas to find it. So velocity equals, this means wavelength times frequency, or velocity equals wavelength divided by period. So depending on what you have, just like all the other physics you guys have done, whatever you have is what formula you use. Alright, number 14. Mac and Tosh are resting on top of water near the end of a pool. Mac creates a surface wave that travels the length of the pool and back in 25 seconds. So it sounds like our period is 25 seconds because that's one cycle, length, back. So big T equals 25 seconds. Always write our stuff first. The pool is 25 meters long. Determine the speed of the wave. Well, we know that the distance is, because there and back, right? So 25 is 50. With that being said, we just look at our formula and whatever we have, we use, right? So I'm going to go velocity, and it looks like I'm going to use a different one from that one, but that's okay. Is distance over time. Just straight up velocity is distance over time. My distance is 50, my time is 25. And therefore, my velocity is 2. In this case, my wavelength is sort of my distance. So notice how it kind of translates. Wavelength is your distance, and your time in this case is period. That's okay. We got it. All good. All right, 15. Fisherman with sonic range determines the depth of a lake. The wave travels 1,210 meters per second through the water. So that's our velocity. Meters per second. And it requires, so our time, really our period, 0.02 to travel to the lake's bottom and back. How deep is the lake? Okay, so we have our velocity equals wavelength over period, sort of the same thing we just did, except in this case we have our velocity. I'm kind of going to the left, so just beware. 1210 equals, we don't have the wavelength because that's my wave's bottom, or how deep there and back. We don't have that. So I'm going to do my little wavelength symbol, just a symbol. I don't know what it is, whatever. And our period is 0.02. So in order to solve this, hopefully you guys have got this by now, this deep into physics, we need to get the wavelength by itself, which means let's go ahead and multiply this whole side by 0.02, cancel it out. Since it's on the bottom, we can do that. And then the left side, 0.02. And our final wavelength should be about, what is that, 24.2? Make sure I got that. 1210 times 0.02, 24.2. Awesome. And I'm going to box my answer. Good. All right, 16. So we're getting to the point where we're doing a lot of repetition, so that's good. The water waves below are traveling at a speed of 3 meters per second. Cool. So we have a velocity, 3 meters per second. And splashing periodically at Wilbur's porch. Each adjacent crest is 6 meters apart and splashes Wilbur's feet upon reaching his perch. Okay, so our wavelength is 6 meters, right? How much time passes between each successive drenching? Okay, so we need to find our period. So our time passes between each cycle, or the length of time for one cycle. How much time did that? Answer and explain using complete sentences. Okay, so explain it if you want. Just give me a quick sentence. I'm really more concerned about the how you're supposed to do this formula. So velocity equals wavelength over period. My velocity is 3. My wavelength is 6, and my period is big T. Same thing. We need to get this T by itself, so I'm going to do it same way. There's different ways to do it. I'm going to multiply everything by big T, which cancels it on the right side. Then multiply the left side by big T. So now we're going to have 3 times period equals 6, right? I'm going to divide that 3 out to get T by itself. By 3 out, 6 divided by 3 is 2. So they give us a little space for that. Okay, so I'm going to save the next page for another video, so it's a faster upload. If you guys got any questions, let me know. Easy.